We're going to divide complex numbers. Dividing complex numbers is very similar to dividing our radical numbers. What we're doing is we're multiplying the top and the bottom by the conjugate of the denominator. Remember that the conjugate is the opposite sign in the middle. And you're always multiplying by the conjugate of the denominator. What you're doing is you're getting the i's out of the denominator. So I don't want any i's in the bottom or the denominator. So I don't want any i's here or any i's here. So we can multiply by the conjugate. So I can multiply, this is really 0 plus 3i, so I can multiply by negative 3i over negative 3i. Remember that we're really just multiplying by 1. This is just an unsaid 1 value. It's a particular number 1 that we picked, kind of like how magicians pick a particular hat that they're going to pull a rabbit out of, right? We're picking a very particular number 1 to make it do what we want it to do, to get that I out of the denominator. Okay? You could also, again, choose to multiply by positive 3i over positive 3i, just because the denominator is a monomial. Okay? So if we multiply here, we've got on the bottom, 3i times negative 3i is negative 9i squared. On the top, we've got the negative 3i times 5, which is negative 15i. And then we've got the negative 3i times 2i, which is negative 6i squared, right? Well, we remember that our I squareds are really negative 1s. So this changes the sign here, and this changes the sign here. So this turns into negative 15i plus 6 over 9. And then we're going to check to see, can I have any common factor with these 3 parts? Which I do. Each one of these is divisible by 3. So negative 15 divided by 3 is negative 5i. 3 goes into 6 twice. 3 goes into 9 3 times. And then technically we should switch it around, or it would most conventionally be written as 2 minus 5i over 3, because we want it as the a plus bi. Just note that you could also have this written as 2/3 minus 5/3 I. This, I would say, is atypical. It's still a correct answer. I would say this one is the most conventional. Okay? Again, they are all still correct answers, all of these 3. Okay? So if we look at the next one, we have to multiply by the conjugate, because on the denominator we have a binomial. So we're forced to multiply by the conjugate. So we're going to multiply by negative 2 plus 2i on top and on bottom. Right? So when we multiply by the conjugate on the bottom, it will get rid of our I values. So we're going to multiply on top. We've got negative 8i times negative 2 is positive 16i. And then we've got negative 8i times positive 2i is negative 16i squared. So don't forget your squared part. Remember that we can change the squared to be a negative 1, so we just can cross this out and change that to a plus. On the bottom, we've got the negative 2 times negative 2, which is positive 4. And then remember, what happens with your conjugate is that you have parts that cancel out. So we've got, this is negative 4i, and then this is positive 4i, and then our positive 4i and our negative 4i really go to 0i, which we don't need to write. And then we have our last term that we can multiply. The negative 2i times the positive 2i is negative 4i squared. Again, our I squared switches to a positive. So then we have 4 plus 4 on the bottom, which just gives us 8. Notice there's no I on the bottom. That's the whole point of doing this, that it gets rid of the I on the bottom. And then on top, I'm going to switch it around, so this is our real part, so it has a positive with it. So we're going to have positive 16. Oh, I don't need to write the positive. So 16, and then plus 16i. Notice when I switched the order around that I kept the signs the same. Both of them are positive, both of them are positive. Then I look to see if there's any common factor with these 3 parts. There is. 8 goes into all of those, so I'm going to divide each thing by 8. So 8 goes into 16 twice, 8 goes into 16 twice, 8 goes into 8 once. So we get 2 plus 2i over 1, which is really just 2 plus 2i. And that becomes our answer for dividing our imaginary number. Okay. Let's have you try this one. So pause the video, try it, and see what you get. Okay, you should have paused the video. You should have this answer, so this should be -9 minus 11i that you're timesing by. I'm gonna, for the moment, erase this part here so that it doesn't get in the way. I guess I can write that over here. Okay. So on the bottom, when we're multiplying the conjugate, we really care about the firsts, which is the 81, and the lasts, which is -121i squared. And then the outside and the inside are the ones that go to 0. Or, let's see, let's use this color. This is -99i and +99i, which go to nothing, right? So then on the top, when we multiply, I'm going to show that you can still use your boxes. So off to the side, we're going to do 5 plus 7i, -9 minus 11i. So in our first box, we've got -9 times 5, which is -45. And then we have -9 times 7i, which gives us -63i. And then we have -11i times 5, which is -55i. And then we have -11i times 7i is -77i squared. Okay. Well, our I squared, I'm going to cross this out and change the sign here. So then we have like terms with the -45 and the +77. So if we do -45 plus 77, that gives us 32. Right? And then we have like terms with our i's. So we have -55 plus a -63 or -63, either way you can think of it, is -118i. Right? On the bottom, I still need to finish simplifying. We simplified the top fine. Again, the I squared turns into a -1, which we'll do negative times negative, which turns to a positive. So then we do 81 plus 121, which gives us 202. So we have 32 minus 118i over 202. Now I'm going to check, is there something that goes into all of these? Well, all of these are even, so they're at least divisible by 2. So if I do 32 divided by 2, it gives us 16. If I do 118 divided by 2, that gives us 59, so minus 59i. And then if I do 202 divided by 2, that gives us 101. And I'm going to check and see, is there any other common factors here? There are no other common factors, so then this is my answer for dividing our complex numbers.